Hello, my phenomenal viewers, and welcome on today's episode. On today's episode, we are going to be answering this question, which is under thermodynamics, and the question reads: a resistance thermometer has a resistance of 80.0 ohms at steam point, 68.0 ohms at the ice point, and 70.1 ohms when immersed in a liquid. What is the temperature of the liquid? So, as you can see, the question is under thermodynamics, and I would recommend that you should go grab a book and a pen and join me as I provide a solution to this question. So, solution. So the question reads: a resistance thermometer. So it shows that this thermometer has its thermometric property to be its resistance. Now the thermometric property of a thermometer is simply the property of that thermometer that has the ability to vary linearly or to change linearly and continuously with temperature. So in this case, it is the resistance of this thermometer that has the ability to change linearly and continuously with temperature. And we've been given a different resistances at different temperatures. So this resistance thermometer has a resistance of 80 ohms at steam point. Now what is steam point, or what is the temperature at steam point? Steam point is simply the point at which water boils, and water boils at 100 degrees Celsius. So we're given the resistance at 100 degrees Celsius, which is what? 80 ohms. So the resistance at 100 degrees Celsius, which is the steam point, in this case is 80.0 ohms. We've been given the resistance at ice point. Ice point is simply the point at which pure ice melts, which is 0 degrees Celsius. So the resistance at 0 degrees Celsius has also been given to us to be 68.0 ohms. And now we've also been given the resistance at a certain point that we don't know. Let us call that point X, when this thermometer is what? Immersed into a liquid. So this resistance Rx is 70.1 ohms. So these are the different resistances at the different temperatures. So we've been asked to determine the temperature at point X. So now, for us to know the temperature at point X, we are simply going to use this formula, which is temperature at point X is equal to resistance at point X minus resistance at ice point divided by resistance at steam point minus resistance at ice point, all these times 100 degrees Celsius. So this is a formula that you need to take note of. This formula is a standard formula that you need to know. So this is the formula that we are going to use to determine the temperature when this resistance is immersed in a liquid, and it records a resistance of 70.1 ohms. So the temperature at X, or the temperature when it is immersed in that liquid, will be given by Rx, which is the resistance that it has when it is immersed in that liquid, 70.1, minus R at ice point, which is 68, divided by R at steam point, which is 80, minus R at ice point, which is 68, all these times 100 degrees Celsius. Now, when you simplify this, you are going to have the temperature when it is immersed in that liquid to be theta x to be 17.5 degrees Celsius. So this is the temperature when this thermometer is immersed in a liquid and its resistance is 70.1 ohms. So this is the temperature of the liquid. So this is how you go about answering this question. And if you loved this video, please help me and share so that you can get to many students as possible. And if this is also your first time to come across any of my videos, please do not hesitate to either subscribe or follow me so that whenever I upload videos like this one, you will be notified. And thank you for watching. Stay blessed.